Hello friends, this is a 2-mark question on DBMS and topic relational algebra. The question reads as follows. Given two relation R1 with 3 attributes A, B and C and R2 with 2 attributes D and E with C as a foreign key in R1 referring to R2. Suppose there is no violation of referential integrity constraint in the corresponding relation instances T1 and T2, then which of the following relational algebra expressions would necessarily produce an empty relation? In the question, we are said that C is a foreign key in R1 referring to R2. That means C refers to some column in relation R2, and from the options given we can figure out that the column is D. So we have following relational structure for the given question. Now the question further says that there is no violation of referential integrity constraint. That means each value of C must exist in relation R2 for attribute D. So using this sample relational database, let us examine each of the given option. In the first relational algebra expression in option A, we get the value of attribute D in relation R2 which are not in relation R1 for attribute C. So we will have D3, D5 and D6 in our example. So this relational algebra expression will not result in an empty relation. Thus option A is wrong. Now let us look at option C. In this relational algebra expression, we first perform the theta join between relation R1 and R2 on condition C is not equal to D. So we will get all the combinations where value of C is not equal to D, and if we perform projection operation on attribute D, we will have all the values of D, which is nothing but D1 to D6, and finally if we subtract values of C which occur in relation R1 from these values, we will have D3, D5 and D6 same as the relational algebra expression in option A. So option C will not give an empty relation. So this is also a wrong option. Now let us look at option D. In this option, we perform theta join between relation R1 and R2 on condition C is equal to D, and finally project the attribute C. So we will have D1, D2 and D4 in the result. Thus this relational algebra expression is also not returning an empty relation. So this is a wrong option. Thus the correct answer to this question is option B, where we subtract the values of attribute D in relation R2 from the values of attribute C in relation R1. That is, we get all the values for attribute C in relation R1 which do not occur for attribute D in relation R2, and from this we can easily verify that it will return an empty relation. So the correct answer to this question would be option B. Thank you.